and going through the Mathematics Unit 2 Calculator Allowed higher tier paper from the autumn-November 2018. The one thing I will say is I've already recorded the intermediate video for this. There's a link in the description below that if you want to go and look at the first 9 questions, you just need to go and click that link and sort of fast forward through the video to those 9 questions, which are the same as the last end on the intermediate. Okay, so the first question that was on the higher only paper says a googol is a number 1 times 10 to the power of 100. Circle the value that is 90% of a googol. Now what they want you to be able to do here is to work out the multiplier of finding 90 is times in this by 0.9, okay? So 0.9 times 1 would be 0.9 times 10 to the power of 100, okay? Now the problem is in standard form that doesn't work because it's got to be a number between 1 and 10. So I'm going to make that 10 times bigger, but if I make that 10 times bigger, I've got to make this 10 times smaller to keep it the same. 0.9 times 10 is 9, times by 10 to the power of, if I'm divided by 10, I'm divided by 10 to the power of 1. 100, take away that 1 would be 99. So it'll be 9 times 10 to the power of 99, which is the last one there. Okay, next question says, sketch the curve y equals tan for the values minus 180 to 180. Now this is all about just knowing the structure of what these graphs look like. My advice to you, if you don't know anything about these graphs, is to go onto Desmos, type in the graphs, play about the scales, and learn them inside out. Okay, you should have done a lesson before me doing this about how you actually draw these graphs. The knowledge that you should have for an exam is that you have asymptotes at 90 and minus 90. So I'm going to draw those in, 90 and minus 90. And then my graph for tan will go through 0, and it is a graph that looks something like this. And then it mirror images here. It never quite gets that asymptote. Okay, so it looks something like that. Now this graph here is translated 180 degrees so that it should look exactly the same here. And then effectively it would go up there as well, but I only need to go up to 180. But this positive bit here, we want that to be the same here. Okay, now my graph's going to look a bit strange if I have those 2 lines there, so I need to either rub them out, which I haven't got a rubber, which is a bit silly in hindsight, but what I will do is I'll point at that and say asymptote. I'll point again and say asymptote. Not part of my graph. Okay. Over the page, question 12 says, calculate the total surface area of a solid hemisphere with base radius 29 centimeters. And the diagram is not drawn to scale. Now, the key word here, which we're not used to seeing in these papers, is the fact that it's not the total, the fact that it's surface area. Now, in terms of what this shape would look like, that is half a sphere. So if I try and draw that as like an empty one there, effectively we'd cut that open and flatten that out. We need to go and find a formula. I'm hoping it's going to be on the front or the second page. And we'd have that circle area as well, okay? So what we want to do is work out the area of the circle, which would be pi r squared, so pi times 29 squared. And we'll work that out. I might just leave that in pi form for now. Pi brackets 29 squared is 841 pi. If I press SD, I'll just get a really long, horrible number. Sorry, press SD, get a really long, horrible number that I'll then need to just keep on writing out. So I'm going to leave it in pi for now, although I'll write my final answer as centimeters. It's not a non-calculated paper. If I come back to my paper here, we're told here, sphere. Now we're not after volume, we're after the surface area, but that's of a sphere. We have half a sphere, a hemisphere, which means half a sphere. So basically, we'd have that formula there, 4 pi r squared, but we need to divide it by 2. Okay, so area hemisphere is going to equal what I just wrote down here. 4 pi bracket radius 29 squared all over 2. So that's going to go into my calculator. Four pi brackets 29 close brackets squared all over 2, which comes to 1682 pi. So my total area is going to be 841 pi plus 1682 pi. So if I just say plus 841 pi equals, and I'll SD that answer and write that in. So that's 7926.2 to 1 decimal place. Okay. Okay, then, so moving on to the next question. Question 13. Now, these questions here on a higher tier paper for a reason. They're looking for you to use your mathematical knowledge to try and pull things out. These are two quite tricky questions to do. Now, first of all, it says fully factorise, it's worth 3 marks. Use that to your advantage to think, right, it's got to be about 3 minutes work. You're not going to get this done in one step, which would be to say, oh, well, C's in both. That's going to be C squared minus D squared. Okay? That's only going to get you 1 mark. You've only done one step. This thing in here, can that be factorised? And you're supposed to be able to spot that it can, that it is the difference of 2 squares. The difference of 2 squares has exactly the same letters or numbers in both, but literally the signs change. So if I did C times C, I get C squared. I get a plus, no I wouldn't, I get a minus CD, then a plus CD, then a minus D squared. Okay, so anything that's a square number, take away another square number, can be expressed as the difference of 2 squares. So that's what they're expecting to see. Okay, now this one here again, this can be done really, really long if you think, oh, right, squared means times by itself. So I'll put 5 bracket e minus 1 bracket e minus 1 and then solve it that way. There's a much easier way to spot this, which is we've got e minus 1 in both of these. Okay, so e minus 1 is going to come out as a common factor. And then this will become 5 bracket e minus 1. Okay, the squared, I've taken that outside. So if I times that by that, I get it squared again. Plus 3. Okay, now focusing purely on the inside here, I can expand out 5 times by e minus 1. Now there's no squares. It would be 5e minus 5 plus 3. I can then not factorize. I can simplify inside to get 5e. And then minus 5 plus 3 would be minus 2. And that would be absolutely fine to be finished there. You can expand that out, but I would argue that then you want to factorize it. Okay, so that's probably a much quicker way of doing it rather than trying to expand out here. Okay, question 14. So this is all about being able to visualize what's going on here. It says a load of information there that they've actually gone and written on the cuboid. And then it says calculate AG. So where's A? G? It wants me to work that out there. Now to work that out there, I need to know what the base of it is. It should be that. Now that gives me a right angle triangle going through the cuboid. The problem is I only know 1 out of 3 sides. I'm supposed to find this side. I need to see if I can work out this side here. Now, looking at the bottom here, I've got another right angle triangle which I know 2 sides of. Okay, so if I do 7 squared plus 3 squared and square root it, that will tell me what that hypotenuse is, and that's EG. Okay, so I'm going to say EG squared is equal to 7 squared plus 3 squared. So EG is equal to the square root of 49 plus 9. So EG is equal to the square root of 58. Okay, now I know that is root 58. I know that is 5. I can just do Pythagoras' theorem again to work out what AG is. So I'm going to say AG squared is equal to root 58 squared, which will effectively cancel out, plus 5 squared. So AG square AG is equal to the square root of 58 plus 25. Let's work out what that is. 58 plus 25 is 758, just 58. 83. And if I square root that answer, I get 9.11 to 2 decimal places. Okay. Question 15. 3 unbiased dice, so normal dice, are rolled at the same time. Calculate the probability that they'll all land on 5. Now, this is quite a common question that you usually ask on the intermediate paper about what's the chance that I roll double 3. And you get loads of really wrong answers, like 2 out of 12 and so on. It's just working through your probabilities. What's the chance that I get 5 the first time? 1 out of 6. Times by, what's the probability I get 5 the second time? 1 out of 6. So if I... Sorry, I had the video freeze again there, so I'm just recapping what I just said. Probability of getting 5 the first time, 1 out of 6, times by the next probability, 1 out of 6. It's rolling 3 5s, so I times it by 1 out of 6 again. So really, really, really unlikely that would happen. So 1 out of 6 times by 1 out of 6 times by 1 out of 6. Okay, that gives me 1 out of 260. Now, the next question, B, I thought was pretty tricky. It says 4 unbiased dice are now rolled. Calculate the probability that at least 3 of them will land on 5. Now, I'm going to go through the 3 bit in a second, but this is the key bit here. At least 3 of them. Okay? So, the chances of me getting throwing 4 dice and getting at least 3 land on 5 is that I get the probability of being 5, then 5 again, then 5 again, and that last one has got to be not 5, okay? Now, mathematically, I'm going to write that as 5 dash. 5 dash means that I don't get 5. I could have had it that I got the probability that I got 5, then not a 5, then a 5. I could have got another way of getting it, which would be 5, 5, not 5, 5, 5. And finally, I could have got it that my first roll wasn't 5, but then my next 3 were. Okay, so there's 4 ways of getting this. So the chance of me getting a 5, then a 5, then a 5, then a not 5 would be 5 out of 6. So it's that final probability that changes. Okay, now that's going to happen in all of these situations here. So rather than writing it out every single time, I know there's 4 lots of this, so I want to times that answer by 4. So that would work out at being 4 times by 1 out of 6 times 1 out of 6 times 1 out of 6 times 5 out of 6 works out at being, I'm just going to write out what I've done, so 1 out of 6 times 1 out of 6 times 1 out of 6 times 5 out of 6. Now that works out at being 5 out of 324. Now that is not my final answer because it says at least 3. So this way here was working out 3. To get at least 3 would include this answer up here as well, because that's 4. Okay, so I could have rolled 3 of them. The chances of me, the probability of me rolling 3 5s was 5 out of 324. But then to get at least 3, I could have also had, well, hang on, all 4 going on to that. Okay, so if I then add on to that, sorry, before I add on to that, I just realised I've made a small mistake. This is getting 3. To get 4, 4 all land on 5. Well, we already know what the probability of 3 of it happening is. I times that by 1 out of 6 as well. So if I do 1 out of 216 times by 1 out of 6, the chance of me rolling 4 dice and them all landing on 5 is 1 out of 1,296. The chance of me rolling 4 dice and 3 of them land on 5 is 5 out of 324. But then for it to be at least, I need to add on the chances that I get all 4 landing on 5. So I'd add on 1 out of 1,296. Okay, so we get 5, 3, 2, 4 plus 1 out of 1,296. Okay, so I get the answer 7 out of 432. Question 16 is a trapezium rule question by the looks of it. Yes, I've been told here to use the trapezium rule with ordinates at 0, 1, 2, 3, 4, 5, and 6. Now, what that means is where you see 0, fire a line up to the curve. Now, it's already done in terms of the axes, but then I need to repeat at 1, 2, all the way up to 6. So, 1, 2, 3, 4, 5, and 6 is already done for me because it's fired down there. I now label these as areas, so I'm going to call this area A, B, C, D, E, and F. I'm going to work out each area, and then I'm going to work out an estimate for the area bounded by this curve. So area A would be the base, so 1 times by the height. Now, hang on, it's not a rectangle, this one. It goes from 18 up to 20, okay? So this is a trapezium, so it's going to be half of the parallel sides, so 18 plus 20, and then times by the height. Now, I don't actually need my calculator for that. What's in between? What's the average of 18 and 20? 19. 19 times 1 is 19, okay? For B, I can read off its corners here, so 20 and also 20. So that, even though it's not quite a rectangle, we're just going to treat that as a rectangle. So it's going to be a 20 by 1 rectangle. So 20 times by 1 is 20. For C, we've got 20, but it goes down to 18. So actually, it's going to be exactly the same as A. So it's going to be a half of 20 plus 18 times by 1, which is 19. For D, come down quite a bit now. So we're going to get a half of 18, because that's where we ended there. Sorry, my camera just froze again. Sorry about that. So D, we know it comes up to 18, because that's where we finished off with C up here. And then this one here works out being 14. So it'll be 18 plus 14. Now again, save me using my calculator. What's the average of 18 and 14? What number's in the middle? What's half of 18 out of 14? 16 times by 1, 16. For E, which is this one here, that look more like an E. That's also a trapezium, so it's going to be a half of 14 where we finished off with D, plus 8. What's the average of 14 and 8? What's that? 11. 11 times 1 is 11. And then D is actually technically a triangle, so you just do a half base times height. Is a half of the base, so 1 half base times height, and then times by the height of 8. So 1 times 8 is 8, half of that is 4, so that answer there would be 4. Add all those together, put it through your calculator, we get 19 plus 20 plus 19 plus 16 plus 11 plus 4, gives me an answer of 89 units squared. Okay. Okay, over the page we've got question 17. Have a quick read of it, try and get your head around. Okay, so we're getting very close to the end of the paper now. So this really should be telling you that if I'm looking at triangles, then I'm looking at sine and cosine rule. So I'm going to go and get my front of my paper ready so I can have a look at the formulae again. Now, we've got to try and get our heads around what they're asking us. They want me to go and work out the length of CD. They give me a 7-mark question. If it's a 7-mark question, I'm likely to be using both the sine rule and the cosine rule at some point. CD is this length here. I already know 2 sides here, and they want me to know a 3rd side. Now, that will be using the cosine rule in there, because the cosine rule, at the end of the question, you will know all 3 sides and an angle. The problem is we don't know an angle here, okay? We don't know this one here or here, but looking at the other triangle, I've got an angle that's opposite here. Now, can I work that angle out? Do I know the side that is opposite this angle? I do, it's 11. And then the other angle I know, so 37. Do I know the side opposite? I do, it's 13. So I can go and work this angle out, use opposite angles at equal, and then use the cosine rule. So 2 sides and 2 angles at the end of the question would tell me to use the sine rule. Because I'm going to be looking for an angle, I'm going to, so see here, we've got A over sine B, B over sine B. I'm going to put the angles up on top. I'm transposing it. It's the same thing to say sine A over A is equal to sine B over B, and so on. They're the same thing. If you're looking for a side, you keep the sides on the top. If you're looking for an angle, keep the angles on the top. It makes the manipulation easier. Now, I'm looking for sine B here, okay? So I'm going to say sine B over 11 is equal to sine A, so sine 37 over 13. I now want to get the B by itself, so I'm taking the divide by 11 over as a times by 11. So I get sine B is equal to 11 times sine 37 over 13. And then I'm just going to cross that out, put a bracket around it and say sine minus 1 just because I'm running out of area, okay? Or out of space on my answer sheet. So B is equal to shift sine 11 times 37 over 13, round to the side, close bracket, equals 30.8 blah blah blah. Okay, sorry, 30.6 blah 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 degrees. Okay, you do not round that answer yet because we haven't finished the question. We're 3 marks in, 30.6 degrees dot dot dot. Okay, that's what this angle is here as well. Okay, so now I'm looking at using the cosine rule. Notice that here the letter at the start and the angle at the end are the same, little a and capital A, and these two sides here, B and C, are the two sides here and here. Okay, so using that to help me now, so we can have both, I want to find this side little b. I know what little d is, I know what little c is, so I want to have capital B and little b because that's what I'm looking for, and I know what that angle is there, okay? So I'm going to have that written as b squared, we have it just so you can see it, b squared is equal to c squared, 7 squared, plus d squared, so 10 squared, minus 2bc, so minus 2 times 7 times 10, you times those two numbers there together with 2, and then cos, now I'm going to use the ands button in my calculator, but I'll just say 30.6 dot 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 there degrees. Okay, now that can go into my calculator in one go. 7 squared plus 10 squared minus 2 brackets 7 brackets 10 cos ands equals. So b squared is equal to 28.5111 blah 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 squared, not squared, sorry, and then b is equal to the square root of that answer. Again, I haven't rounded because I haven't finished. So what I do is I put into my calculator square root ands, and I get the answer 5.3 to 1 decimal place. I can round now because I've finished. Okay, so that'd be centimetres, that'd be to 1 decimal place. Okay, final question to finish. It says solve the equation 7x plus 1 over 5x plus 2 equals 1 over x plus 3. Now the problem with this is we don't like the denominators, so what we're going to do is cross multiply. So I'm going to get 7x plus 1. I've got a bracket around it because it's got 2 bits. I'm going to bring over the divide by x minus 3 to times by x minus 3. And similarly here, I'm going to put brackets around the denominator there to make sure those 2 bits are the same. Now I'm going to expand out. I'm going to get 7x squared plus 21x plus x plus 3 is equal to, well, anything times by 1 is just the same. I'm now going to bring everything over to be a quadratic, so I'm going to leave nothing on this side. I'm going to keep everything on this side because the x squared coefficient was positive. 21x plus x is 22x. Take away 5x is plus 17x. And then plus 3 take away 2 is plus 1. Okay? If you try and factorise that, you'll find you can't. So what you need to do is use the quadratic formula. Again, going all the way to the sheet here. Where's the quadratic formula here? We're using this guy here. I've identified what my a, b, and c coefficients are. A is the coefficient is the number in front of x squared. So plus 7. B is plus 17. We can just say 17. And c is plus 1 or just 1. And that's quite a nice one. Usually you get some negatives in there that make a bit of a difference. What I do now is say minus b. So I'm going to change everything here to just literally the letters are changing for open brackets. Okay, literally nothing has changed there from there except their open brackets. Now, B was here and here. So B, 17, goes in here and here. The next one I had was A. So A goes in here and here. A is 7, so 7 goes in place of there and there. And then finally, C was the last letter, so C has 1 going there. I'm now going to put that into my calculator once where I add it, once where I subtract it, and I'm going to collect my answers. They want me to round my answers to 2 decimal places, so that was the hint to use the quadratic formula. Okay, so into my calculator, fraction button first, minus brackets 17, I'll do plus first, square root 17 squared, minus 4 brackets 7 brackets 1, 2 brackets 7 on the bottom, press equals, SD it, and I get minus 0.06 to 2 decimal places for my first answer, and then I just use the replay button to delete the plus, change it to a minus, and I get the answer minus 2.37 to 2 decimal places. And that was the last question on the paper. If that was useful, please hit the subscribe button to get access to any more videos that I release and everything that's in the back catalogue. Hopefully that was useful. Thank you very much.